Sabah al Khair students. So here's my video of Krichoff's current law part 3rd. Here I'm going to give you some tricks so that Kirchhoff voltage law is quite very lengthy process to solve. So here we have a Kirchhoff current law. Instead of using such a big matter, such a big equation, lengthy process, lengthy divides or plus minus etc., you can opt this method. You can solve any question with Kirchhoff current law. Okay, so here in this video, in part 2, I have tried to solve certain questions with Kirchhoff voltage law. So same question I am doing this in part with the help of Kirchhoff's current law. Okay, and if you want me to solve more numericals on the Kirchhoff current law, and if you have more, I know there's so many live circuit problems, so you can just comment me and send it to me. I'll definitely give you a reply and I'll try my best to solve it. Okay, and give you answer as soon as possible. So please don't forget to comment. Okay, so here is my first numerical that I had solved with the help of Kirchhoff voltage law, and today we are going to do the same numericals with the help of Kirchhoff's current law. And now you will realize after the end of this video how simple we can solve the very big problems, very big meshes with such in only in a one line, in a one go. So now the life become much easier with this law. Yes. So here is my question 1, and this is here is B and here is A, and we have 10 ohm here, and here is 5 volt, and this cell is 2 volt, and we have to find the value of X. Remember in my previous video we had to find the value of X, so we took current over here and just apply across this Kirchhoff current law, and then second time here, so that we can able to find the value of X. So now look how can we able to solve this same question with the help of Kirchhoff's current law. Again, VB minus VA is equals to 4 volt. Okay, so this information was given in the question. And hello, my name is Arwa and my channel is AB Tutorials Learn Hard. Okay, so basically what is Kirchhoff's current law? It says simple, voltage divided by resistance is equals to current. This is basically we can able to find the value of the current across any resistor, okay, so how can we able to find out? Just have a look of it. Look here, VB minus VA is equals to 4 volt. What does it mean? VB must be at higher potential and VA must be at lower potential. It means across this the battery is some of kind like this, joined like this. This is higher potential and this. It means VB minus VA they had given is 4 volt, right? So across these ends we have 4 volt going on, and here we have 5 volt. So what can we do now? We can do one thing. So 5 volt is at higher potential, always minus higher potential from the lower potential. Okay, higher potential minus, always subtract higher minus lower. Okay, so here's 5 volt and here's 4 volt across these terminals, and of course it is plus 5 volt, right? Plus 4 volt. So all high potential is 5, so 5 minus 4 volt is equals to 1 volt. So rest of the voltage we left with 1 volt across this 10 ohm. across this 10 ohm we have only 1 volt, right? So how can we use this formula? We have voltage is equals to 1 volt, we have resistance is equals to 10 volt, so current going on is 0.1 ampere across this, right? And since we know that current I is flowing all through this here, okay, so I current is also going in this branch. So we have at this point, let's say it is EF. So now we have the value of current, and we know that V is equals to IR on here at EF. Okay, I'm talking about EF. So R is equals to X and I is equals to 0.1 volt. What is the value of V? V is 2 volts. So we have 2 divided by 0.1, that is 20 ohm. Remember, same answer we got in our previous video. So only with this, just we had applied this, no more remembering of the signs, conventions, anything. And this is our Krichoff's current law. Okay. Now question number 2 was it was something like this. This one, okay, and so this is our question number 2. 30 ohm, 40 volt, 80 volt, 40 ohm and 40 ohm. Okay, and this is 30 ohm. Okay, 40, 80, 40, 40. Okay, fine. So now same question, we have to find the current across each resistance. Okay, so how can we apply the Krichoff current law across this? First we just label it A, B, C, D, E, N, F. Okay, fine. Always remember this across this terminal, look carefully, look, okay, this is 0 and this is plus 40. Okay, we have potential difference, no? So potential difference, it must be 40 plus 40, it must be 0. That's why we have a potential difference. So plus 40 will go this direction, plus 40 volt, fine. And here we have 0, 0, 0, 0, 0, same, there is no resistance to drop the voltage, so 0, 0, 0, 0, 0, and here is also 0. Correct? Fine. And since this is the same wire that is going across till B point, so it must be 0 because there is no resistance. Same volt, same 0 volt over here also because no resistance, no voltage drop. Okay, but now this is plus 40 volt, but you cannot go to F with plus 40. Why? Because there is a resistance in between F point and plus 40. So if you try to jump over this plus 40, it means voltage will drop, and we don't know how much voltage will drop across 40 ohm. So just let it be like this for some time. We will do something for it. Whenever you stuck at this point, just leave and go to other branches also. Okay, same problem we have here. Here we have plus 80 in this direction and here is 0 volt. Okay, so when you jump, because this is 0, okay, we just have put 0 over. You can put 0 anywhere and you can take X value anywhere. Okay, but here we have 80 volts. So if you try to jump from higher to lower potential, it means this must be minus 80 volts. Correct? If you try to jump, you have minus 80 volt. Okay, not plus, this is minus, this is plus because we have plus over here, so we are going in plus 40. This is, we are jumping from higher to lower, so it is minus 80. Okay, Again, if you try to jump from -80 towards the point E, there is a resistance, it means there is a voltage drop, and we don't know how much voltage will drop. Okay, fine. What we have to do, we have to find the potential difference across this point of the resistors and this point of the resistors, so that we can find the potential difference, and potential difference upon resistance gives you current, right? So we don't know what is the potential at this point, we don't know. So what we can do, we can took one variable, okay? Just let's say at this point we have y. Yes, y is our potential at point F. Why? Because why I have taken y at F. This is y volts, okay? Y volts, y volt, okay? This is my y. So why I'm taking y because at this point, because there's so current is dividing. This is my junction point, and current is dividing across here. Some current is going here, some current is going here. So basically, I don't know where is current going, whether it is going to this branch or whether it is coming to this branch. I don't know anything. Okay, so I just have taken at this is my junction point, and I know this is all current is dividing across this. You can take y at any point also, no problem. Okay, so I have taken y at here, and I don't know whether current is coming towards the y or whether current is going towards the A point. So what we can do, we just took y at high potential. Y is my high potential now. So look, at this point, resistance this side we have y potential, and at this point we have 40 volt. So what are we left with? We are left with y, since y is at my high potential, now always minus higher and lower potential. Okay, so y minus 40 divided by y minus, since it is plus 40, so y minus 40 divided by 40 ohm. This will give me current. Fine. Now, and if you are thinking how can I take y as high potential, so don't worry, if it answer will come negative, so it means current is going towards this, and if it is positive, so my value is correct. Okay, sign will take care of it, you don't worry. Now at this point, this potential is also y, because same wire, no resistance in between. So here we have y is at my high potential. Okay, so y minus of 80 plus, y minus of 80 divided by 40. Can you see y? This is already minus, so y minus of 80 divided by 40. Okay, fine. Now what about this point? This point is also y. So here at this side of the resistors we have y, and at this we have 0. So y minus 0 divided by 30 plus y minus 0 divided by 30. As we know, Krichoff current law says all the summation of the current will give you 0 at the junction point, right? Current at this junction. Now you may think, since I have taken y as high potential, so all current is going out from this branch. Since I have taken y, so you must be thinking all current is going like this, but it is not possible. Some current has to enter it. That's only then we get equality sign, right? So you are right. Basically, if at some branch current is negative, so automatically the arrow will change, so sign will take care of it. We will get a negative sign, so don't worry about it. Y will be negative, or any of the current will be negative across any branch, so sign will take care of itself automatically, you don't worry. Okay, since at this point we don't know whether current is coming towards or whether current is going to this branch, so that's why for my security I have taken this y at high potential, and the current is going, I'm just taking current is going outward. Okay, fine. So just solve this question as you can see, this is 0 0 0, so all zeros to go to that side. So we are left with y minus 40 divided by 4 plus y plus 80 divided by 4 plus y divided by 3 is equals to 0. And if we take LCM, so we are left with 12. So 4 3s are 12, so 3y minus 120 plus 3y, 4 3s are 12, 3 8s are 24, sorry 24, okay, so 240, right? This is 240. 4 3s are 3 8s are 24 plus 4y is equals to 0. Now we have 3y, oh my pen, wait, I'll just check. Okay, so this is my equation and here I am with my new pen. Okay, so 12 goes to 0, so we are left with 3y plus 4y, that is 10y, and minus 120 plus 120 will give me plus 120, that is equals to 0, or 10y gives me minus 12 minus 120, okay, or y is equals to minus 12. And as you can see, my y is negative, so as my assumption was y is at high potential was definitely wrong, because it is low potential, it is minus 12, y is negative. Okay, so now across FC branch, FC branch means at this point we have, you remember we have y minus 40, we have phi minus 40 divided by 40. So y is not my answer. Basically I want to find the potential difference divided by the resistance. So potential difference was y minus 40 divided by 40, and my y is minus 12 minus 40 divided by 40, which will give me minus 52 divided by 40, that is 4 1s are 4, 4 3s are 12, so 1.3 ampere current. Fine, 1.3 ampere current. Okay, and let's see what across ED at this point, this and this potential difference, this is again, this is y plus 80, right? Y plus 80 divide, this is y, remember y plus 80 divided by 40, y plus 80 divided by 40, which is y value is minus 12 plus 80, so 40. Okay, it gives me, that is 8, that is 40. Hope I have not done any mistake. Okay, fine. 4 1s are 4, 4 7s are 28, 1.7 amperes. And look, the sign is positive. It means from this branch the current is going like this, and here we, since at this branch, you remember this is negative 1.3 ampere absolute negative, it means current, there is an incoming current, and here we have assumed that y is high potential, but we were wrong. Since positive, it means the current is in this direction, outward current positive, incoming current negative. So let's find the current status at this point. So we have y minus 0 divided by 30, which is equals to minus 12 divided by 30, and that will give me 3 4s are 12, right? That is 0.4. Wow, negative 0.44, 3 4s are 12, yes. Okay, 0. amperes. So as you can see, I have found current across FC, across any branch, that is we have 40 ohm, we have 2 resistance, 30 ohm. We find current across each resistance. So my last question that we had done is somewhat like this. $12V, 8V, 6V, 54 ohm and 28 ohms. Okay, this was my last question. And in this video, last question too. So what we can do right now, we can have in this branch, look across this branch, what we have 0 over here. Okay, and here we get plus 6 volt, and here we have 0V. Okay, fine. Now we have plus 12V at this at high potential, and this is at low potential. So you cannot write 0 over here. Of course 0 is already taken over here. So we can take, since we are jumping from high to low potential, so we can take this is minus 12V. Minus 12 will go across here. Fine. So between these terminals we have minus 12V. Okay, we have to subtract high to low potential. So if you are thinking 6 is at high potential and 12 is at low potential, so don't worry, you can have 6 minus 12V. That will give you 18V, right? So we have 18 voltage potential difference across this resistance. So 18 divided by 54 will give you 2 9s 18, 2 2s are 4, 2 7s are 14, 3 3s are 9, 3 9s are 27, 3 1s are 3, 3 3s are 9. That is 1 by 3. Okay, so we have 1 by 3 ampere at this branch, that is across 54 ohms. So across 54 ohms we have 1 by 3 ampere. Fine. Now look at this branch. We have 0 over here and we have 8V over here. So we cannot take plus it right now. What we can do, we can go from higher to lower potential. So this side will be minus 8V. Okay, so minus 8, this is single wire, so this is again minus 8V. So how much current is flowing across this resistor? Across this resistor is, of course, high minus lower, so plus 6 is high volt. Okay, divided by 28. So we are left with 14. That is 6 plus 8 divided by 24. That is 14 divided by 20. Sorry, not 24. It is 28. 28. 7 2s. That is 1 by 2 amperes. Now, this is according to this sign, that is I have minus, since I have minus from high potential to low potential, I have high potential to low potential. So basically my answer is positive. What does it imply? That current is going outward, right? Current is going outward. Positive sign means current is going, and incoming current we generally take negative direction. So and if you want to find the current in this branch, so it's for sure, if the current is going according to my sign convention, it means this and this. Current is going like this. So from this branch, there must be incoming current. This incoming current divides in two parts. So according to Krichoff law, if we say this is I1 and let's say this is I2 and current across this is I3, so what we can say this I1, what we can say this I1 must be that is incoming current is I1 and outgoing current is I2 plus I3, fine, equals to 0. according to sign convention. Okay, this current, this and this we are going. Okay, so minus I1 we have plus 1 by 3 plus 1 by 2 is equals to 0. So minus I1 is equals to minus 1 by 3 minus 1 by 2, that will give me 6. Minus 2 minus 3 minus I1, or minus I1 is equals to minus 5 by 6, or I1 is equals to 5 by 6. So it means whatever direction I have taken, it's all good because the answer is positive now. So it means we have I1 and I2 and I3 like this. Okay, so this is all about this Krichoff current law. Hope you have enjoyed. So best of luck. Goodbye. Thank you so much.